Okay class, today we're going to finish up this vector read problem. So last time we met we looked at the XLS read, and hopefully you've got this worked out so you've got points. If it's a 2010 or 2013 Excel file, you're going to need to include the extension XLSX. If you only have 2007 or below, it'll just be XLS. So I've got the location of points 1 and points 2 stored in these two arrays. So in P1, I'm going to access the array A, entries 1 through 3, to get the Cartesian vector locations of point 1, which is just the origin, 0, 0, 0. And then I've got point 2 located and stored in the array in locations 4 through 6. We said that was going to be point 4, 5, and 3. What I want to do now is calculate the length of the vector from the origin out to point 2. So I will define a value dx, the distance from the origin out to point 2, as P2 entry 1 minus P1 entry 1. So those are the x locations of point 2 and point 1 respectively. And I'll say dy is simply point 2 entry 2 minus point 1 entry 2. Those are the y locations of points 1 and 2 respectively. And then dz will likewise be point 2 entry 3 minus point 1 entry 3. I'll have to go back and fix this mistake before we end up getting in trouble. So let's save this and see if it'll run down here with what we've got. Okay. See what we got here. So we've got dx is 4. Well, first of all, we've got P1 is 0, 0, 0. P2 is 4, 5, 3. That's what we need. Dx is 4, dy is 5, and dz is 3. So that is working. So let's go and comment what we're going to do next. Let's calculate the vector length. Using the distance formula. Which is going to be the square root of dx squared plus dy squared plus dz squared. Alright, so we'll define our vector length variable. And it helps, especially if you're going to come back later, to make these variables as descriptive as possible. So I'm going to use the Matlab function square root sqrt. And we'll say dx squared plus dy squared plus dz squared in the parentheses. Alright, let's save this right quick and see if that's going to work. I like to check my code every few lines and make sure I haven't messed anything up. So we'll run this selection. It's going to run this yellow area, so we'll see if we Alright, there we go. We've got everything working as before, but now we have the vector length calculation as 7.0711. So now we can go ahead and define the unit vector. So let's comment that. So compute unit vector entries. And remember, we're going to say that the cosine of the angle alpha is going to be equal to dx divided by the vector length. We'll also say that the cosine of the angle beta, which is between the actual vector and the y-axis, is going to be what? dy divided by vector length. If you're not sure about these, please go back and look at the video where we defined them. And then finally, the cosine of the angle gamma. Now, depending on what textbook you use in physics or statics, they could call this theta x, theta y, and theta z instead of alpha, beta, and gamma. But it's all the same. So dz divided by vector length. So this gives us the cosine of these three angles. So let's go ahead and define those. I'm going to call this ux, the entry in the unit vector for the x direction. That's simply going to be dx divided by the vector length. And the y entry in the unit vector I'm going to call uy. And that will simply be dy divided by the vector length. Then finally the third is going to be uz. It will be equal to dz divided by the vector length. Alright folks, let's check this. Let's save it and see if it runs. Okay, here we go. These are our unit vector entries, and again we can check this to see if it's satisfied by squaring each one of these, taking the sum of those squares, and that should be equal to 1. So that is again the first check that I told you about. So let's finish up by defining the force vector in Cartesian vector coordinates. Or Cartesian vector notation. So again, that's just going to be the force magnitude times the x, y, and z components of the unit vector respectively. So we'll say Fx is simply equal to 500 times Ux. Then Fz is equal to 500 times, oops, I don't want to do y next, not z, Edgar, come on. So Fy is equal to 500 times Uy, and then finally Fz is equal to 500 times Uz. And let's stop there, save it, and see if it gives us the values that we're looking for. Okay, it did run. And always check these by hand. Again, this is our second check. We can basically take these individual force vector components, square them, take the square root, and we should end up with what, our 500 Newton force magnitude. Now guys, that's all I'm going to take you through. There's bonus work where you can actually do the 2 checks in Matlab. If you want those 5 bonus points, please do them. Guys, I know some of you are worried about your grades. We'll get those things posted and cleared up. If you have missed any assignments, I will certainly give you a chance to make those up with no penalty for full credit. You guys have a great afternoon, and I will talk to you tomorrow. Thanks.